Hello and welcome to my video, lesson 8.3 on trigonometric functions. So in order to talk about a function, we have to understand that a function means it's going to be on a graph. So we're going to be talking mostly about y equals sin x, but we will also talk about y equals cos x, and we will also talk about y equals tan of x. Now, instead of calling it of x for now, we're going to just call it sine of theta because it's going to be easier to transition from theta on the unit circle and everything we've learned so far to a graph. And so we're going to do, all of that. We're going to do all of that, but with theta. So cos theta, tan theta, like that. And we know that according to our understanding already of the unit circle, we understand that sine theta is y, and cos theta is x, and tan theta is y over x. So we're going to use that knowledge in order to move on. And the reason why we want to go away from these x's here is simply because of this trickiness with the cos. We are going to use the x in order to transition from the unit circle to the actual function. Okay, so let's go ahead and draw out our unit circle. I'm going to use green because I don't want it to mess up with what I'm going to do below. And what we're going to do is not draw the whole unit circle, just focus on the parts that are really, really important. And that's going to be all of our points going around the outside. I'm also not 100% sure if I'm making a perfect circle here, but you're going to see that it looks roughly right. It's a little bit lopsided, a little bit squished, a little bit wider than it is tall, but that's okay. Ballpark, that's a circle. Okay, so just those points, what are the coordinates of these points going around? Well, hopefully you can tell that this is going to be, if it's on the unit circle and the radius is 1, this is going to be 1, 0. This is going to be 0, 1. This is going to be -1, 0, and this is going to be 0, -1. So we have our coordinates, which means our x and y values, which are x and y values. But what we need to still figure out is the degrees going around. So this is 0 degrees. This is 90 degrees. This is 180 degrees. This is 270 degrees. And this is back to 360 degrees. Okay, and then last but not least at all, we can also have the radian measurement, which is going to still be 0 to start, but it's going to be pi over here. It's going to be pi over 2 over here. It's going to be pi over here. It's going to be 3 pi over 2 here, and it's going to be 2 pi over here. And we know, based off the last couple topics, we know that we can actually go past 360, or we can have negative numbers, but we're just going to stop there and use this to start drawing our unit circle. Okay, so this is fantastic, really important. And how this works is we have x, y values, i.e. the coordinates, around the unit circle, and those coordinates are what go onto our new function. So the circle is not a function, okay, because it doesn't pass the vertical line test, right? It's not a function. So what are we going to do to get a function? Well, I'm going to match my colors with what I have written down below here. Whoops. So this is going to be blue, this is going to be red, and purple. Okay, so we're going to start with the most classic of them all, which is the sine function. So I'm going to do this in blue. The sine function is y, right? That's what we said. So that means it's the y coordinate as we go around the unit circle. Now, we're going to go from 0 to 360. So we're going to call this in the center 0 degrees. Maybe I'll just write it. Yeah, I'll just write it right above or right on top, 0 degrees. And I'm going to call this over here 360 degrees. I'm not really happy with how that's going to look. I'm just going to write it underneath, and then we're going to draw our lines on top. So halfway in between is going to be 180 degrees. Halfway between that is going to be 90 degrees. And then halfway between 180 and 360 is 270 degrees. So I'm going to try to draw the same thing in the negative direction, and we're going to deal with that in a little bit. So negative 90 degrees, negative 180 degrees, negative 270 degrees, negative 360 degrees. And I'll just write a 0 degrees here. Okay, so given all of those values, and obviously we could also write the radian results as well. Okay, given all those results, we can now transition from the unit circle and create a graph. So at 0 degrees, or 0 radians, what is the value of sine? Well, sine is the y value. So what is the y value right here? It's 0. So that's where we're going to put our first dot. Then we're going to go around. What is the y value at 90? Well, it's 1. So we're going to make this a 1 here. We're going to make it a 1 by marking off that this is a 1. So we're going to just notice that we have the positive 1, the negative 1. At the top, we have the positive 1 here at 90, which is what we just saw. Then we have, if we look here at 180, we have it back at 0. Then at 270, we have it back at negative 1. And then at 360, we're back at 0 where we started. So you can see that as we go around the unit circle, it literally is making a circle on top, but at the bottom here on our actual function, we end up having this curving value. And you could, find all the different coordinates around the unit circle and get it more precise, but I find that only the 90s going around the circle are all that you really need to graph this nicely. So hopefully you can see that pattern happening. Now, if we continue this, but in the negative direction, remember negative degrees around the unit circle are going to go this way. So what is the sine function here? Well, it's negative 1. And then it's 0. And then it's 1. Oh, it's a little bit high. And then it's 0 again. So we could continue this pattern into the negative directions. And it would look like this. So again, all of those are sine, all of those are the y values from the unit circle put onto a sine function, onto a graph, where the x-axis is theta. Right? This is the theta axis. Okay, so let's go ahead and now graph cos. Cos is the x value, okay? So cos is the x value as we look around. So it starts at 1. It goes to 0. Then it goes to -1. Then it goes to 0. Then it goes to 1 again. Okay, so try your best to make a nice curving function like that. It's maybe not perfect, but it's the rough idea. Okay, and it looks something like that. So if we now continue this into the negative direction, we're going to have a 0 next, then a -1 over here, then a 0 again, and back to a +1. So we continue this pattern up and around. And again, my drawing is maybe not 100% perfect, but it's pretty close. It gives us a pretty good idea of what this will look like. And yeah, this can continue this way. I'm putting arrows on because you know that we can go past 360. And all of these things that I'm saying in degrees, they also hold true in radians, right? You look at this and it goes from 0 to 2 pi, 0 to -2 pi in the negative direction. Okay, so those are the main two trig functions, and I'll say by default we're going to use sine, because why? Well, if you look at sine, it's like the older brother, okay? Sine is the older brother, and cos lags behind. It's always behind the sine. Cos wishes it could be as far ahead as sine, but it can't. So it's lagging behind. So you can see that every one of these points is just simply behind the sine function. And so what we can do is transform the sine function into the cos function when necessary. So that's why we will not really worry about the cos all that much. It'll come up every once in a while. We need to know about it, but it's not going to be the main focus, both in this course as well as later. Again, it will happen. You have to know about it, but it's not the focus. That's why we call them not just trigonometric functions, but we call them, we call both of these curves sinusoidal functions. And I don't know if I spelt that right, but it's somewhere in that ballpark. Okay, what about tan? Tan is the weirdest one, okay? If sine and cos are like brothers or brother and sister, whatever, then tan is like the weird uncle. Tan is the weird uncle because tan is just maybe the black sheep in the family, is just the loner. He's by himself. He's different than everybody else. So, and that's not a bad thing in general, but it is. It makes them weirder. So tan is y over x. Okay, tan is y over x. So when we divide by x, we have to keep in mind we have a problem sometimes. When do we have a problem? We have a problem when we divide by 0. Because if we divide by 0, we can't do that. That's something we learn really early on, even in elementary, I believe. We get an error. So we're going to have it undefined there. And we know from our rational function unit that if we do that, if we divide by 0, it's an asymptote or a whole. In this case, it'll be an asymptote. So what we can do is we can look at this situation and we can try to draw ourselves a couple of asymptotes. Wherever x is 0, well, where is x 0? 90 and 270. So we're going to just quickly make some asymptotes at 90 and 270, and also negative 90 and negative 270. So there's some asymptotes for our tan function. Now, we can also see that if y is 0, because y is on top, if y is 0, then that means that the whole function is going to be 0. 0 over anything is just 0. So where is y 0? Y is 0 here and here. So y is 0 there, which means tan is 0 there. So tan is going to be 0 at all of the same locations that sine is 0. So if we now make that graph, we can make it do what we kind of want here. Just, this is not going to be a perfect graph. It's going to look something like this. And yeah, it's just going to do this shape as well. If you look at the sine and cos values, like in this first part from 0 to 90, both sine and cos are positive. That's why the tan is positive. In the 0 to negative 90, only one is negative. So they're both, so the tan is going to be negative. And you can see the same thing from 90 to 180, one of them is negative, so tan is negative. From 180 to 270, both are negative, so tan becomes positive. And you can see that kind of pattern repeating. Okay, so hopefully that didn't get too messy here. But we have now sine in blue, cos in red, and tan in purple. So if we now take a look at these different functions, we can see that there's certain aspects to them that are certain like names, vocabulary that we need to know, some key facts about them. So we've got something called the period. Period is when does the graph repeat? So if you'll notice this graph, oftentimes what we're going to do is we're going to compare either peak to peak and say what's the distance from here to here? That's our period. Or we'll go from trough to trough and we'll compare that distance and we'll say whatever that distance is, that's our period. And that works just fine. But oftentimes it's kind of hard to see those ones. So what else could we use? Well, we can go from the 0, but we can't go directly to the next 0 because that's going to be half the period. We have to go here. Why? Well, this is in the middle going up. This is in the middle going down. Doesn't count. This is in the middle going up. So you need to make sure that they're the same type of point. And if you pick 2 points on the same graph, so sine, cos, or tan, that are the same value and the same direction, then at that point, you have a period between them. So from here to here is one period. So that's what we're going to take a look at here. If you look at our sine graph, it goes from 0 to 360. So that's our period. Going from 0 to a 0 to a 0, that's a period. Another way to say that is 2 pi. And we know that actually cos is going to have the exact same 2 values here for a period, whether that's degrees or radians. Okay, the amplitude for both sine and cos is 1. So what does the amplitude mean? Well, the amplitude is the distance from peak to the middle or from trough to the middle. Those two should be the same. So the distance here is 1. The distance here is 1 because it's going -1, but it's the distance, not displacement, if you want to think physics. So both of those are 1. And then we have the equation of the midline. So what it's asking here is what's the equation that makes this line that ends up in the middle of our graph? This is the midline. Well, this equation is going to be y equals 0. So when y equals 0, we have a line going down the center of our graph, and that's the middle of our graph. And it's same thing for cos. Sine and cos are identical functions. That's what I want you to notice right now. They're identical in every way except the cos is transformed. Okay, the domain is going to be x is in the real numbers, and that's going to be true as well for the cos. And the range is going to be between -1 and +1. That's the biggest and smallest value of y that we can have. Okay, so this is sine, cos. Let's take a look at tan. Tan is our wonky neighbor. Okay, he's our weird uncle. He's our the black sheep in the family. He's the weird person. Okay, so tan, it doesn't really follow the same pattern that cos and sine follow. You'll notice here, hopefully, that tan actually repeats itself more often. Like in what we've drawn here, it's repeated itself twice, 3, 4 times, whereas sine and cos only repeated themselves twice. So the period of tan is actually going to be just 180 degrees or pi, because it's going from 0 here until 180, and you can see it's already repeating the same point in the same direction. Okay, the amplitude, well, there is no amplitude, like it's not applicable here. It just doesn't exist. It doesn't have an amplitude. The equation of the midline still is going to be y equals 0. The domain is a bit of a problem, but the range is y is in the real numbers. Okay, let's talk about the domain. The domain is a problem. Why? Because there are these asymptotes. So that means that x is in the real numbers, yes, but x has some restrictions. X cannot equal 90 degrees plus 180 degrees k, where k is an integer. What does this mean? Basically, 90 degrees plus 180 or minus 180 and any integer value times 180. So 90 plus 180, 90 plus 360, 90 plus 540, 90 plus 720, etc., and also minus that value. So all of these things, x cannot equal those. So it's actually a repetition of things that x cannot equal. If we continued this graph out, we'd have more and more asymptotes. Okay, yeah, I hope this video helps you better understand trigonometric functions, and I hope you come back for the next video, which is going to be talking about transformations on trig functions. Hope the video helped, and good luck.